All right, so section 1.5, section 1.5 deals with applications of quadratic equations, okay? Guys, in essence, what this means is word problems, all right? In all these problems here, for the most part, we're either going to try to factor if we can, or we're going to use a quadratic formula. So the first problem here says solving a problem involving projectile height. It says if a projectile is launched vertically upward from the ground with an initial velocity of 100 feet per second, neglecting air resistance, its height s in feet above the ground t seconds is given by, and it gives us an equation there. Okay, so I want you to think about what we're doing here. It says a projectile is launched vertically upward. So think about we have a bottle rocket and we're going to shoot it upward, okay? This is the equation that's going to describe the height. Assuming it's going straight up, it's not going to curve, and we always know that they curve, but this is not going to curve. It's just going to go straight up, okay? So the one thing I want to mention here is it's important that we understand what each of the variables stand for. So the height they're using for the letter S. That's the height in feet. T is the time in seconds. Okay. So when I read the first question here, it says, after how many seconds will it be 50 feet above the ground? So I'm looking for the time when I know the height. I know the height's going to be 50. So that means that right here I'm going to plug in the number 50. So I'm going to write 50 equals negative 16t squared plus 100t. Okay. So guys, the first thing I'm going to do here, again, I'm going to move everything over this way so that this guy here isn't negative. So that's going to give me a 16t squared, a minus 100t, and a plus 50 equals 0. Now, to make my numbers a little bit smaller, I'm going to divide everything by 2. Okay? It's just going to make my numbers just a little bit smaller. So now I'm going to have 8t squared minus 50t, plus 25. 0 divided by 2 is still 0. Okay, now that we know that part, let's write down our numbers A, B, and C. Okay, so A is 8, B is negative 50, C is 25. Okay, so I'm going to use my quadratic formula. Okay. So guys, if you notice, I didn't even try to start factoring this guy out just because the numbers are so big. It'll probably take me longer to factor. If I even try to do that, it's just going to be more straightforward to use the quadratic formula, okay? So let's see, t equals negative. B is the number negative 50, so I'll put a negative 50 right here. Plus or minus square root, negative 50 squared, okay, minus 4 times A we said was 8, times C, which is 25, all over 2 times 8. Okay. Alrighty, so let's see, that's going to be negative of negative 50, positive 50. Okay. Negative 50 squared is going to give me 2,500. Let's see. Make sure I'm doing this right. Yes. Okay. So let me see. Let's see. Now I'm multiplying 4 times 8 times 25. So let's see. Let me take my calculator real quick. Let's do that here. Let me grab it. Put it on. 4 times 8 times 25. Should be 800, okay, minus 800, oops, there we go, minus 800 all over 16, okay, 50, plus or minus, let's see, what's 2,500 minus 800? 1,700, I want to say, minus 800 should be 17, yep, 1,700. All over 16, okay, we're almost done, equals, okay. So guys, I'm going to use my calculator here because we're going to do an approximation. I want to know what is the square root of 1700. Okay, I'm coming up with 41.23. Okay, so 41.23. So now I have 50 plus or minus 41.23 all over 16. Okay, so we're going to do two things here. We're going to write our answers in green. Remember what plus and minus means. Plus and minus means exactly that. So I'm going to take 50 plus 41.23, and I'm going to take that number and I'm going to divide it by 16, because that's the number I have on the bottom. So when is it going to be 50 feet above the ground? At one time it's going to be at 5.7 seconds. Okay, that's one time. Now the other time is going to be 50 minus 41.23, and divide that by 16. And the other time is at if I go to two decimal places, 0.55 seconds. Okay, so I want you to think about this here, right? Here is the ground. Say this is 50 feet. This thing shoots up at 0.5 seconds. So half a second, it's already up there. And it goes up and it comes back down. When it hits it the second time, it's at 5.7 seconds. Okay. Alrighty. Now part B says, how long is it going to take for the projectile to return to the ground? Okay, so remember our equation. S equals negative 16t squared plus 100t. When it returns to the ground, the position on the ground, guys, is 0. Okay, because this part only has two terms, I can always factor something that has two terms. So from here, I'm going to factor out a negative 4t. So 4 goes into 16 4 times, minus, because we factor out a negative, 4 goes into 125 times. Okay. So now I have negative 4t equals 0, or 4t minus 25 equals 0. So this is going to give me t equals 0. If I move that 25 over, I get 4t equals 25. And then if I take 25 and divide it by 4, let's use our calculator again. 25 divided by 4 is 6.25. So the question says, when is it going to return to the ground? At 6.25 seconds, right? That's when it's going to, by the time it hits the ground, it's already at 6.25 seconds. All right. Let's take a look-see at the next one here. All right, so let's just see what this one's asking us to do. It says height of a projectile. If a projectile is launched vertically upward from the ground with an initial velocity of 45 feet per second, neglecting air resistance, its height, s feet above the ground, is given by, and they gives us an equation there. Okay. Now, the question here is saying, which equation should be used to determine the height of the projectile after 2 seconds? So, just like I said before, we want to make sure we understand what each of the variables stand for. Remember, the height is s, right? T is the time in seconds. The question is saying, which equation should be used to determine the height after 2 seconds? So what we're doing here is we're going to say, well, if the time is 2 seconds, what variable stands for the time? T. So which one of these equations here, A, B, C, or D, has the variable t substituted with the number 2? B. Right? It's B.